Today's lesson is on angles, and we have another postulate to learn. Some of this will be review, but never hurts to have a refresher. So in angle, we have two different rays or segments that have the same endpoint make up an angle, and the rays or the segments are known as the sides of the angle, and then their common endpoint is the vertex of the angle. So in my diagram here, ray AB and ray AC create the sides of this specific angle, and because they both share the endpoint A, that is the vertex of this angle. Now, notation over here, there are 4 different ways that I can name this angle. I want you to pause for a moment, pause the video, and see if you can come up with those 4 names on your own, and then rejoin me. Alright, so the first thing I can do is I can just name it by the vertex, angle A. That's it, one simple letter. Now, the reason I'm allowed to do this here is because there's only one angle at vertex A. If there's more than one angle at vertex A, you have to use 3 letters to name the angle. So another way I can name this angle is angle BAC. So that's using 3 letters, or angle CAB. Notice in both of these cases that the vertex is the middle letter. And there's one more way to name this. You notice in here I have this number 1. I could call this angle 1. So those are the 4 ways to name this specific angle in this picture. So remember, if there's only one angle there, you can name it just by the vertex, single letter. If there's more than one angle, you have to name it with 3 letters. And of course, you can always name it with 3 letters if you want, or if a number happens to be there, you can name it by the number. Alright, classifying angles. Hopefully when you start to look around, you'll see geometry all over the place. We're going to classify the angles. I'm just going to point out some angles in this picture. You don't need to write anything down on the screen. We'll review it on the next screen. So classifying angles, if you'll remember, the angles we have acute angles. So if you look in the picture, acute means they're going to be greater than 0 degrees but less than 90 degrees. So if I look and I trace along right here, that would be an acute angle there. Okay? The next angle we're going to go with is obtuse. Sorry if the green doesn't show up very well on here. I'm going to color code my thing. So obtuse, it's going to be greater than 90 degrees but less than 180 degrees. So if I look, let's see, where can I find one? Oh, it's right here. This angle right here is greater than 90 but less than 180. So there's an obtuse angle. Next, we're going to go with a right angle. And right angle, I hope you all know, is equal to 90 degrees. So if we look here, right here we have a right angle. And remember, we mark right angles with the little box to tell us that they're right angles. And if you look, there's actually quite a few right angles throughout this picture. You can also find multiple acute and obtuse angles as well. And the last one we're going to talk about is a straight angle. A straight angle is equal to 180 degrees, so basically it's just a straight line, but they decided to need another name as a straight angle. So if you look, we have a straight line right here, so there is a straight angle. And of course you can find multiple straight angles throughout this picture as well. Alright, so this slide is just a recap of what we discussed on the previous slide. Take a moment, pause the video, copy these pictures and inequalities and equations down. One thing real quick, classifying angles means you're going to tell me if it's acute, obtuse, right, or straight. If I ask you to name the angle, then you would name it like angle A, angle B, whatever. So there's a difference between naming an angle and classifying an angle. Naming it, you're giving it a name, like you have your specific name. Classifying it, you're telling like what family it belongs to. Like you are all students at Garland High School, that would be classifying you, but then if we name you, we're giving you your specific name. Okay, congruent angles, we have angle A and B here. I created these to make them congruent. The way we mark angles as being congruent in pictures is we use arcs. So I draw these little arcs. That's like using the tick marks to show that segments are congruent. And remember, we write this angle A is congruent to angle B. Remember, congruent means they're the same size and the same shape. Right? And then also we could write measure of angle A equals the measure of angle B. And in this case, we're saying that they're the same size. So, notation is very important. We talked about notation with segments. When you have the congruency symbol with angles, you're not going to have the little m that represents measurement. When you have the equal sign, you have to have the little m that represents measurement. So just make sure you're paying attention. Notation, notation, notation. Alright, the angle bisector, if you think about bisector, bi means two, like a bicycle has two wheels. In biology, you dissect stuff, so you're cutting it, so sect means to cut. So bisector means it's going to cut something in two. So an angle bisector is a ray or segment that cuts an angle into two congruent segments. We're going to cut it directly in half. So in my picture here, we'll call this A, B, C, and D. So ray BD bisects angle ABC. Notice I have to use 3 letters to name this angle because there are multiple angles at vertex B. And because ray BD bisects angle ABC, that tells us then that angle ABD is congruent to angle DBC. Or we can also say that the measure of angle ABD is equal to the measure of angle DBC. Once again, notice my notation. Congruent sign, no M, equal sign, M. Alright, next we have different pairs of angles that exist. One pair is adjacent angles. Adjacent means they share a side and a vertex, but they don't share any common interior points. So like this angle right here and this angle here, we'll call this angle 1 and angle 2. Those are adjacent angles right there. They share this common side, they share this vertex here, but they don't share any interior points. The other one is supplementary angles. They make a straight line. So like this angle, we'll call this angle 3 and this angle 4 up here. If you can see, change colors here. So these two angles here make up a straight line. They add up to 180. So if two angles add up to 180, they're supplementary. If two angles make a right angle, like you can see right here, this angle here and this angle here make a right angle, they add up to 90 degrees. Those are complementary. And then we'll look at some other angles on the next page. Don't worry, there's a recap sheet at the end for you on all these different types of angles. Here we have, I want you to look at this line and this line. They create an X. Whenever you have an X, you have vertical angles. They share a vertex, but no common points. So I'm going to label these 1, 2, 3, and 4. Angle 1 and 3 are vertical angles because they're opposite of each other, and angles 2 and 4 are vertical angles because they're opposite of each other. Alright, so here is your recap page for the different angles we just talked about. Notice with complementary and supplementary, they don't have to be adjacent. They just have to be two angles that add up to either 90 degrees to be complementary, 180 degrees to be supplementary. They can be adjacent or non-adjacent. So pause this, write down everything from this page, and then move on.